Hello and welcome to another video on the graph series. Today we are going to cover a very important question that interestingly most of the other graph playlists or bootcamps do not cover. And I will tell you why. This question is a small variation of the question that we did last, which is number of islands question. Now it is a very popular question, but this question most of the people don't cover because they assume that it is a small variation, so you should be able to understand it. But according to me, it is very, very important that you practice all the variations so that you understand that how your solution can completely change with a very small change of the question. So according to me, you should not be missing any such questions in the playlist. Do not try to take any shortcuts. You should be understanding the concepts properly. You should be noticing these small differences in the questions. So that is why please do not miss any videos in the series and stay tuned, and let's get started now. Before we move ahead, I would just like to take a moment to remind you to be consistent and make sure you do not miss any videos in the graph series. So make sure you subscribe, hit the notification bell icon. You will also stay motivated, and you have no idea how much your support will mean to me. There's so much of free content available on the channel. There's HLD, LLD, DSA, Advanced C++, tutorials, mock interviews, and so much more. So if you think I deserve your support, please subscribe, hit the notification bell icon. And there's obviously a bunch of stuff that I cannot do on YouTube, like mock interviews, live interactive classes. So we have educourses.com. We have live courses, self-paced courses with live doubt solving support, which both of them we have mock interviews, and we have a lot planned in LLD, HLD, Advanced C++, DSA, and so much more. You have no idea. So if you want me to be part of your further learning journey process, please check it out. The link is in the description. And now let's continue. So this is the question, number of closed islands. Now, how is it different from number of islands? Let's read the question. So we are given a 2D grid, consists of 0 is the land and 1 is the water. So these are all lands and these ones are water. Okay. Now you can see that some zeros are in gray and some zeros are in white. Why is that? Similarly, for ones, there are some in blue and some in white. Why is that? Let's see. An island is a maximum 4 directionally connected group of zeros, because 0 is land, right? So whenever you can connect zeros in 4 directions, what are the 4 directions? Left, top, right, bottom. So basically just the 4 directions. We are not considering diagonals. So basically these are all forming an island, correct? Now we have to return the number of closed islands. So if we see over here in this example, the answer is 2. So which are the 2 islands? One is this island and the other is this island. Now you must be thinking that why is this not an island? Similarly, why is this not an island? Because unlike the last question, it is not given that on the 4 sides there is water. So it is not given that, so you cannot assume. In an interview, you're supposed to ask this question that on the 4 sides, is there water, is there land, or can I not make any assumption? What should be my answer? Should I include this in my island or not? So these questions you have to ask in the interview. A lot of companies do this. Purposely, interviewers give you half information and they expect you to ask this. Like here in LeetCode, it is given that, okay, this is the output and you can understand that, okay, you don't have to include this. But in interview, you're supposed to think and you're supposed to ask these questions. Okay. So in this example, these zeros are not included because an island is supposed to be surrounded by ones. Is this surrounded by ones? No, because there is no 1 over here. Surrounded by 1 means it should be on all the 4 sides. Ones should be there on all the 4 sides. That is why closed island. Closed. It should have 1 on all the 4 sides. You can see over here, 1 is there on these sides, 1 is there. So if this is the 0, 1 is there on top, 1 is there on bottom. Similarly over here also, either 1 is there or 0 is there. It is not like it is just there and nothing is connected on the top or on the right, correct? So I hope you have understood the difference now. Let's see more examples. So here, this is the only island. Now this will not contribute to any island because we do not have ones around in all the 4 directions. This has 1 in all the 4 directions, correct? Similarly here the answer is 2. Now what are the 2 islands? One island is this, correct? Simple, because it has 1 in all the 4 directions. Next is this island, this, then this, and then this. This is one island. It has ones inside also, it has ones outside also. So there are 2 islands in this. One is this, just this one single 0, and then these are the other zeros. So I hope you have understood the question properly. 0 is the land, 1 is the water. Here we cannot assume that there is water on all the 4 sides. Coming to the intuition of the question, it is very similar to the number of islands question, obviously. What is the intuition? Now we did that using DFS, BFS. We understood that that question can be done using any traversal. Let me just do a quick recap for you. So basically, if I start from any land, suppose I start from here, I traverse to all the land, basically all the zeros that are directly connected, and I mark them as visited at. Okay, we have marked all of these as part of one island. In that case, we also increase the counter to 1, that okay, we have come across one island. Then we see if we come across another 0, we will just increase the number of islands by 1. Now here the tricky point is that we do not want to include some zeros. Basically the ones that are not surrounded by 1s, right? Now how do we do that? Now note that it is not necessary that the zeros that we do not have to include always have to be on edge. Now this is a very important point to notice over here, because in the examples it is given like that these zeros are also on the edge, this 0 is also on the edge, these zeros are all on edges, so we are not including them. But consider the case where suppose these were also zeros, this one and this one, these two were also zeros. In that case, this entire thing should not be included, because then it is leading to some zeros on the edge, correct? Just think if these two ones were zeros, in that case, this would not make a closed island because it is leading to an edge. It doesn't have 1 in all the directions, right? So it is not necessary that we will not include the zeros on the edges. Now it is a very important point. If you have not understood this, just convert these two ones to zeros and see that in that case, all of these zeros do not contribute to a closed island because they lead to an edge, right? So how do we do this now? We have to basically understand that which zeros lead to an edge, right? Edge is our edge case over here. So in that case, what if we try to use the same solution and try to do some pre-computation or try to extend our already solution, okay? Now there are many solutions of this question. You can write the solutions in many different ways, just like most of the other questions in DSA. I'm just telling you one possible approach so that you can still use the solution that you have for number of islands question. You can still do traversal where you just have to do some pre-computation. Basically, we're just extending our solution that was there in the number of islands question. So here what we are going to do is, before we start counting the number of islands, we are going to go through the edges. Like if I start from here and I see that which all zeros are connected to it. Just like how I was doing DFS earlier, I will do DFS before itself. Like in the pre-computation part also, I will do another DFS and I will convert these zeros to ones. Basically, before I start counting the number of islands, I will convert these zeros to ones to make sure that I do not include them in the number of closed islands. So before I start counting the number of islands, before I start saying that, okay, this is forming one island, I am going to do some pre-computation. And what am I going to do? All the zeros that are there on the edge, from there I'm going to do yet another DFS and I'm going to say, these are not zeros, these are ones, because these I do not want to include them. Basically, I do not want to include these, so I will just convert them to 1. I do not want to include this, I will just convert it into 1. So that when I actually start counting my number of islands, when I actually start doing the DFS and then start counting, then those are not included because now those have become 1. So we'll be discussing the code now. I'll be first writing the code in C++ and then in Java. Let's get started. So this is the grid that is given to us. Let's start with just calculating the size. So this is the number of rows, n is the number of rows, and m is basically number of columns. So grid of 0 ka size is number of columns. So we have n and m. So we will start with what? We first have to do some pre-computation. And what do we have to do in pre-computation? We basically have to go through the boundary and do DFS on the boundary, right? So boundary is what? Basically these 4, right? So let's cover this and this first. So the columns, so first column and the last column. How can we do that? So our I is going to vary in these two columns, right? So I'm going to go like I equal to 0, I is less than n, I plus plus, and I'm going to go through these two rows. How do I do that? So basically in this row, what is going to happen is j is always 0, right? So I have to basically go like if grid of I and 0. So basically I'm checking the 0th column at this I and I'm checking if it is equal to 0. Basically if there is a land, I'm going to do a DFS and I'm going to mark all the zeros that are connected to it to 1. Basically I'm converting those zeros to 1s, right? In DFS I'm going to pass basically I and 0 because that is my j right now. Basically row and column I'm passing. Then values of n, m and the grid, correct? Now similarly for every I also have to check what? I also have to check the last column. What is the last column? It is basically m minus 1. Again, I'm going to do DFS only when I have a 0. Basically, only when I have a land, like over here, I have a land. So what am I going to do? I'm going to do DFS on I, and it is m minus 1, and I'm going to pass nm and then the grid. So now I have done DFS on all the zeros that are there in the first column and the last column. So now what am I going to do? I have to go through these two rows now, the 0th row and the last row. How can I do that? My j is going to be varying. So j equal to 0, j is less than m, and j plus plus. So if I have to go through first row, how do I check that? So if grid of 0, so basically 0th row, and j, grid of 0j is equal to 0, then I am going to call DFS. My I is what? My I is 0. My number of row is 0. Then j, then I am just passing nm and grid. Similarly, I have to check the last row also. What is the last row? It is n minus 1 j, and if I come across a land, what am I going to do? I am going to call DFS over n minus 1 and j. I am going to pass the values of nm and grid. So now we are done with the pre-computation. Now is when we are actually going to start our solution. So now to start, I am going to initialize this integer that I have to return. So you can call it RES, you can call it number of closed islands, whatever you want to call it. And now what am I going to do? I am going to go through the entire grid now and do the DFS again. So now all the zeros that do not need to be included have already been converted to 1. We are going to write this DFS function, do not worry. But after we are done with that, we have to go through the entire grid now. I equal to 0, I is less than n, I plus plus. Similarly, j equal to 0. J is less than m, j plus plus. Again, I need to first check whether this ij value, this grid value is basically land or not. So basically, if it is 0, if it is land. So every time I come across a new 0, then what am I going to do? I am going to do RES plus plus. Basically, I am increasing my number of closed islands, and I am calling the DFS again over ij, and I am passing the values of n, m and grid. Now you must be thinking that Keerti, we are dealing with graphs. Why did you not mark it as visited? So what we are going to do is, whenever we do DFS, we are going to mark that value, that row column as visited. How? We are going to convert that 0 to 1. Just like over here, we did pre-computation and we converted zeros to ones. Whenever we do DFS, same thing we are going to do. Whatever ij value we had, that grid value we are going to change to 1. Basically, we are marking it as visited. So every time I am going to come across a 0, that means it has not been visited earlier. That means I am coming across a new island, and that is why I can increase my number of islands and I can return it. I am repeating that. If I come across a 0, that means it has not been visited earlier, because if it would have been visited in this DFS function, I am going to convert that 0 to 1 every time I visit any 0. In this pre-computation also, what I was doing, I was just converting zeros to ones. Here also, every time I visit any value at ij, I will convert it into 1, so that that value is marked as visited and I don't have to worry about visiting it again and again. So every time I find a 0, a new land, that means it is a new closed island. And after I am done with all of this, I can just return this RES. So now let's start writing the DFS function. Do we need to return anything from it? Nope. We do not need to return anything. We just need to mark those zeros to ones, right? And what all things are we passing? We are passing ij, and we are passing nm, and we are passing this grid. So the first thing that I'm going to do is convert the value at grid of ij to 1. So this is what we had to do both in pre-computation and while calculation of the number of islands. So I am just converting the grid of ij to 1. And now we need to visit its neighbors. How do we go through its neighbors? I am going to go through all the 4 directions, right? For that, I am creating this direction 2D array like we have done in the previous questions as well. I need to go to top, bottom, left, right. So -1, 0. So basically, I am decreasing the row by 1 and I am keeping the column same. Similarly, I can increase the row by 1, keeping the column same. Similarly, I can decrease the column and increase the column. So we have to go in the 4 directions. So I am writing another loop, k equal to 0, k is less than 4, k plus plus. And in the 4 directions, what am I going to do? I am going to calculate my new I, which is going to become I plus direction of this k. So whatever is the value, and 0 is going to give me I, right? So this, in my I am adding these values, correct? So basically, I am changing my row. And I am calculating my new j how? in this direction of k is going to give me two values, right? So this is direction of 0, this is direction of 1, direction of 2, direction of 3. Then I'm going to do k of 0 is going to basically, zeros is for my row, and then the first value in this pair is basically for my columns, right? So now I have my new I and new j. Now I have to see whether this new I and new j is again 0 and do I need to convert it again. But again, see, if I was suppose over here and I did find new I, new j, now it can be 4 directions. What if I went here? I could have gone out of bounds. So I need to check if it is safe to go to this new I, new j. How can I check that? I have to check its bounds, right? So I'm passing new I, new j to this new function that I'm going to write. I'm just going to check the bounds, whether it is safe, whether it is within this grid or not. I should not go outside this, like from here I can go to only 2 places, I should not go to these 2. From here I can go to 3 places, I shouldn't go to this. Similarly, from here I can go to the 2 places, not to these 2, right? So I will check if it is safe to go there, and once I'm sure it is safe to go there, what am I going to check? Is the value at this new I, new j equal to 0? Basically, is this land or not? If it is land, then it is part of the island that we are at, okay? Because it is part of the same island, I need to mark again that also as 1. So I am going to call DFS again. And what am I going to pass now? This new I, new j, because it is the neighbor, it is directly connected to it. N, M and grid. So here we are recursively going to the new neighbors now. We are done with the code. We just quickly need to write this function. So we need to return a boolean, and these are basically all integer values, new I, new j, n and m. Now here you can actually just call it I and j. You do not need to call it new I, new j, because it is just I and j that you need to check that is it whether in the bounds or not. So what am I going to return? I am going to return I should be greater than or equal to 0 to be in the bound, right? And it should be less than n. Similarly, j should be greater than or equal to 0 and it should be less than m. So if these 4 conditions are met, then that means it is within this grid, otherwise it is outside. We are done writing the code. Let's try to run it and see whether this works or not. So it is running. Let's submit it and see. So yes, we have passed all the test cases. Again, just like the previous question, we can solve this using BFS as well. I would really encourage you to try writing the code using BFS. That would be absolutely great. Try doing the same question using different approaches. You will get used to it. Plus, what other approaches do you think we could have solved this question with without the pre-computation? If you can do that, please do let me know in the comments. The more we discuss, the better it is. And once you are done with the question, please do mark it as done or understood, so that I know that you are following the series, and it would really motivate me a lot. So don't forget to comment done. And now let's get started with the Java code. So this is the grid that is given to us. Let's get started with calculating the sizes. So we have to first calculate the number of rows, which is basically n. So grid ka length, and m is basically number of columns, which is grid of 0 ka length. So we have the sizes now, number of rows and number of columns. We have to get started with pre-computation. Now what is pre-computation? Basically I have to go to the boundary and mark all the zeros that are connected to the boundary to basically 1. So what is the boundary here? The boundary is basically this column, this row, right? So let's cover the columns first. How can we cover the columns? So when we go to the column, I varies, right? So the row varies. So I equal to 0, I is less than n, I plus plus. So we have to cover both the columns. So how can we do that? Firstly, whenever we have to convert to 1, we have to first check whether it is land or not, whether it is 0 or not, right? So if grid of I, what is the 0th column? So I 0. If the value over there is basically 0, if we come across a land, then what we are going to do, all the zeros that are connected to it, I am going to convert it into 1. So not just that one. So if I come across the 0, not just that 0, but all the zeros that are connected to it, I need to convert them to 1. So I am passing I and 0. So basically this is my ij values. Then I am passing my nm values and the grid. Similarly, so this is for 0th column. Similarly, I need to go through the last column. How do I do that? If grid of I, and what is the last column? It is m minus 1. If the value over there is 0, so if I come across a land like over here, over here, over here, over here, if I come across a land, I will mark all the connected zeros to 1. So here I am passing what? I, m minus 1. So that is my j value, the column value. And then I am just passing the values of n, m and grid. So now I am done with the pre-computation for these two columns. I also need to do the pre-computation for these two rows, correct? How can I do that? So for int j equal to 0, j is less than m, j plus plus. Okay, so I need to go through the 0th row and the last row. So how do I do that? For the 0th row, okay, my I will become 0 and my j will keep varying, correct? So my j keeps varying and I will check if the value over here is 0. Basically, if we have come across a land, then I need to mark all the connected zeros to it to 1, right? So my I is now 0, then j, and I'm passing the values of n, m and grid. Similarly, I'm going to check the last row. And how am I going to do that? So if grid of 0, and what is my last row? It is basically n minus 1. So if that is equal to 0, I am going to do DFS again. And now I'm going to pass the values of 0, n minus 1, and I'm going to pass the values of n, m and grid. So I am done with the pre-computation now. Basically, I've gone through the entire boundary and I've found all the lands and converted all the lands to basically waters, all the connected zeros to ones. So basically, if this was a 0, all the zeros that are connected to that, I've converted them to 1. Right? So not just the boundary ones, but all the ones that are connected to that as well. So now we are done with the pre-computation. Now we will actually start our main algorithm. We will start counting the number of closed islands. So I need to return the integer, right? So this is the integer that I need to return. I am calling it res, you can call it anything, you can call it number of closed islands. And this is what I need to calculate. So I'll be returning that in the end. So now to calculate this also, I again need to go through the entire grid. And how do we do that? For int I equal to 0, I is less than n, I plus plus, and so I'm going to go through the entire grid and I'm going to check that if the value in this grid at ij is basically equal to 0. So I've come across a land. In that case, I'm going to increase the number of closed islands and I'm going to call the DFS again. What are the values that I'm passing? ij, n, m, grid. Now I know that you're already thinking that here we are dealing with graphs, why are we not marking it as visited? So essentially what we are going to do is that when I call this DFS function, so if you notice, it is the same function that I was calling in the pre-computation also. In the pre-computation, what did I have to do? All the zeros that I come across, I'm converting them to 1. Here also I will be doing the same thing. It's the same function. So now what I'm doing is when I convert that 0 to 1, basically I marked it as visited. I am making the change in the same grid. So every time I come across a 0, I basically convert it to 1 and I am converting it to water. Basically, I am not going to come across the same land twice. So every time I come across a 0, it definitely must be a new closed island and that is why I'm increasing it. So if it would have been a land that is connected to the land that we have already seen, it would have been converted to 1 because I have called DFS. Recursively, I would have converted into water. I would have converted into 1. If I have come across a 0, that means I've come across a new closed island. Why closed island? Because I've done pre-computation. All the ones that were not closed, I've already converted them to 1. All the zeros that were connected to my last island have also been converted to 1. So every time I come across a new 0, it is basically a new island altogether. Let's write the DFS function now. So coming to it, private, do we need to return anything? No, right? We just need to convert those zeros to ones. So I'm calling it DFS itself. And what all things are we passing? We are passing the value of I, j, basically row and column. Then the value of n, m, the number of rows and columns, and then the grid itself, which is basically this. And what do I need to do inside this? The first thing that I need to do is basically the main thing. I need to convert the value at this ij to basically 1. That is what we need to do in the pre-computation stage also and while calculating the number of closed islands also. Basically, when we do this, I am marking it as visited, and in the pre-computation, I am converting into water. In both the cases, I need to convert the value at ij to 1. So that is what I have done. That was my main thing. Now after that, I need to visit its neighbors. What are the neighbors? Top, bottom, left, right. So for that, I am going to write another 2D array and I am going to call it direction. And how am I going to go? Basically, I need to go through left, right, top, bottom, right? So first thing that I'm going to do is I need to decrease the row by 1, keep the column same. Second thing, I need to increase the row by 1, keep the column same. Third thing, I need to keep the row same, decrease the column by 1, keep the row same, increase the column by 1. And I need to go through this 2D array. How? There are 4 directions in which I have to go, right? So k equal to 0, k is less than 4, k plus plus, basically these are the 4 directions in which I am going to go, and I am going to calculate the value of new I and new j. So I am at ij. From here, I will go to direction of k. Now direction of k is going to give me 2 values. So this is direction of 0, direction of 1, direction of 2, direction of 3. 2 values. Out of that, the 0th value, which are these, I am going to add to the I, right? So that I get new I. And how am I going to get new j? In my j, I am going to add what? Direction of k and the first value of that, basically these values, to the column. And after I am done with that, so basically I am at the new I, new j. Now what do I need to do? I need to first check, is it safe? Like, is it basically within the grid or not? Is it within the boundary or not? Like for example, suppose I am over here. Here I can go to top, left, bottom, but I cannot go to right because it is out of boundary. Similarly over here, I can go to left and bottom, but I cannot go to top and right. So I need to first check, is it safe to go to this new I, new j? How can I check? I will write another function, new I, new j, and I will pass nm. So in this function, I will check, is it safe to go to this new I, new j? Is it within the boundary? Is it within the grid or not? Once I am done with that, before doing anything, I need to check, is it basically land or not, right? Only if it is land, I need to do further DFS. Otherwise, oh, it's okay, I have just come across the boundary, I have come across 1, I have come across water, right? So if the value at this new I and new j is basically equal to 0, that means if it is land, then what I need to do? I need to call another DFS and I need to pass new I, new j and the value of nm grid. Basically, from this neighbor, I will again mark all the visited lands to basically 111. I am visiting all the connected land and making sure that I mark all the lands in that closed island as 1. So we are done with the code. We just need to write this is safe function. So private boolean is my return type, right? Whether it is safe or not. And what did I pass? I have passed 2 values, ij and the value of nm, right? And I need to check whether ij is within bounds or not. So what are the 4 conditions? Basically, I should be greater than or equals to 0, it should be less than n, and similarly j should be greater than or equal to 0, and it should be less than m. So if these 4 conditions are fulfilled, that means it is in the grid, it is within the boundary. Now let's try to run the code and see. Sorry about the spelling mistake. Let's try to submit and see. Okay, so many test cases are failing. Oh, I've done a very stupid mistake. I hope you all noticed it. Surprised that so many test cases actually passed. So this should have been n minus 1 and j, and I hope all of you actually noticed this. Please do let me know in the comments if you noticed my mistake. So we have passed all the test cases. I hope you like the explanation. Please do let me know in the comments that you understood it or if you are liking the series or not. It will really keep me motivated, and please do show up in all the videos. Please continue practicing and let me know if I can help you in any other way. See you next time.